Hello, welcome to video number 62. We're going to talk about some special rectangle problems. These are two types of problems that are actually on our quiz, and I want to make sure you're ready for it. First one involves picture frames. So here's an example. Suppose a big fan of Nick Jonas decided to put a border around that picture. The original picture was 12 inches by 16 inches, and the border is 2 inches wide. Find the total area of the picture and the border. Now, there's something that people almost always do that is kind of a mistake and get this wrong, and we got to think about this just a little bit. The border is 2 inches all the way around, so it's 2 inches that way, 2 inches that way. It's 2 inches this way, and 2 inches down the bottom. 2 inches all the way around. Now, what most people do is they add 2 to the width and say 14, and they multiply that by what you get when you add 2 to the length, 18, and they come up with an answer. Let's see what 14 times 18 is. And I get 252. But unfortunately, this is wrong. So don't do that. That's a common mistake. And so once you're kind of onto the secret of this problem, you won't fall for this. The reason why is you have to add the border twice to the width. The new width is all of this. All right, so it's the original width, which was 12, and plus 2 inches on each side. So we actually have to add 4 to get 16. And same thing with the length. We're adding 2 on the top and 2 on the bottom. So if the original length was 16, then we have to add 2 2's, which would be adding 4, which is 20. So the new area with the picture of this guy, put a little mustache on him, and the border is 16 times 20. So the total area of the whole thing is 16 times 20, which is actually 320, and our units would be, since this was inches, square inches, or inches squared. Okay, so don't fall for that. When we add a border around a figure, we have to add it twice to the width and twice to the length. All right, next one. So here's another example of this. Suppose Mr. Miller, me, was thinking about putting a frame around a picture of Nick Jonas, but decided instead put a border around a picture of Bulls players instead. The original picture is 28 inches wide and 35 inches long. So let me label those. So the original over here by Noah is 28, and this is 35. Okay, that's the original picture. Now we add a 3-inch border all the way around. So 3 inches this way, 3 inches that way. So the width, the kind of vertical dimension, went up by 6. And if we add 3 inches here and 3 inches here, the length goes up by 6. So the new width would be 28 plus 6, which is 34. And the new length is 35 plus 6, which is 41. And those are the new dimensions we multiply to get the new area. This will be the total area, the picture and the border. So we got 34 times 41. I get 1,394. Again, since the width and length were in inches, the area would be inches squared. All right, easy problem, but you gotta see the trick and remember to add the border twice. Okay, we're actually almost done. This is our last example. Here's another type of problem where we have rectangles that kind of go around some circles. And we're given the radius of the circle, and we're asked for the area of the rectangles. Okay, so these circles are congruent. So in this first example, they both have radius 6. Now, it's a matter of drawing some useful radiuses. This one, or radii, this one's not very useful. But if I draw a radius like this, that's 6. And if I add another one here, that's another 6. If I add one here to the center of that circle, that's 6. If I add one there, that's 6. So all those are 6 because they're all radii. Okay, so 4 6's, that's equal to the length of the rectangle. This must be 24. Same thing going vertically. If I draw a radius up, that's 6, and a radius down, that kind of tells me what the width of the rectangle is. The width of the rectangle is 12. Okay, it's the blue rectangle we're talking about here, not the white border around it, the blue rectangle. Okay, so 12 times 24, which is, I think, 288. Okay, the dimensions were in centimeters, so this would be centimeters squared. Okay, again, this is the type of problem that once you see the secret, you kind of use figure out how many radii make up the width and length, then this is an easy problem. All right, so here, each circle has radius 4, so let's draw a little bit some more useful ones. Let's cut across the center of those two circles. This is 4, that's 4, this is 4, that's 4. So the width of the blue rectangle is 4 fours is 16. Then, let's go vertically here. Let's go through the center of the circles, figure out how many radii this is. This is 4 to the center, this is 4, that's 4, we have a 4 here, this is 4, that's 4. We have 1, 2, 3, 4, 5, 6 radii. 6 times 4 is 24. So we get the dimensions that way. We can use the radii of the circle to figure out the dimensions. So it's 24 by 16. So area equals 24 times 16. Okay, I'm kind of too lazy to get my calculator. I'll work this out with the box method, just for fun. All right, so let's see if we can do this. 24 is 20 plus 4. And you don't have to do this. I'm just too lazy to get my calculator. 10 and 6. So this would be 200. This would be 40. This would be 120. And this would be 24. So 200 and 120 is 320. 360, I get 384. So that box method can be used to multiply things with square roots. We're going to use it to multiply polynomials, but it can work just to do a problem if I'm too lazy to get my calculator. And since the units were inches, it's inches squared. All right, so don't worry about this method of multiplication if you don't know it. The key is find the width and length of the rectangles. All right, I got a beautiful picture here, man. This is a wonderful poster of Albert Einstein. And 2.5-inch border was put around this picture. The original poster was 12 inches by 18 inches. So, okay, figure out the new width and length of the whole thing. And you're going to answer these 3 questions. You're going to find the area of just the original poster. Okay, then you're going to find the total area. That's kind of like the problem examples I did. And then you're going to find just the area of the border. So see if you can figure that out from A and B. If you get A and B, you should be able to figure out C, okay, without too much extra work. Then let's do just one problem like this where we're given a circle and a square around it. Find the area of the square that's inside the circle there, or outside the circle. All right, good luck.